Now, this one asks that you solve it via completing the square. So you've got your 2x squared plus x plus blah equals 7. I'm just going to do that right away. Now, when you have to complete the square, your first rule is that you have to get that first term coefficient of 4. Now, to be honest with you, when you have to worry about all that, let me do it this way real quick. So this is still minus 7. If I'm going to complete the square, I wouldn't do it with this case because, bless you, because it's not a GCF of 2, it's just coefficient of 2. I would have jumped to like quadratic formula because I know what times what's negative 14 is going to get me 1. What I would wind up doing if they're telling you to complete the square with a leading term not equal to 2 or not equal to 1, you factor it out to start with. Excuse me. Actually, let me go rephrase that. Move your 7 first, okay? And then if you factor out the 2 on the one side, we get that. We okay with that? So what's going to happen is that when you take half of your b value, you take half of b, well, what's half of a half? A 4. So our term is going to be x plus 1/4. I square it, I'm going to get a 16th. Okay? But the thing is that when I have this here, I got to put this 2 times the 1/16th there. This is where it gets weird, and we actually spend a lot more time later with coefficients for completing the square not equal to 1. It's one of those deals that it's still a process, but it's a process that kind of stinks. Because what's going to happen, and I think I mentioned this earlier, I think I might have shown you guys a problem. Remember when I showed you that the standard form of a conic section that had all the coefficients that we had to factor things through and go through that? We actually do this method a lot towards the end of next week, to be honest with you. And it's going to be a lot cleaner because these numbers suck. Plain and simple, okay? They're awful. What's going to happen when we get to the completing the square of first term coefficient not equal to 1, it becomes a lot cleaner because you're going to wind up with fractions on the one side that simplify out cleanly, okay? It's still a process. It's just a real crummy process. Okay? And you just continue on from there. I mean, when we got 2, we got 1/8, so this is 50, was that 56, and then 8, so it's 57 over 8. So you're going to get 57 over 8 on this side, divide it by 2, so that gives you, you're multiplying by a half, so this becomes the 16th again. See where I'm going with that? So you divide by 2, it's like multiplied by a half, so 8, 2, get the 16. Take the square root, and now you get your x plus the 1/4 equals plus or minus root 57 over 4, because it simplifies, and then you get x equals negative 1/4 plus or minus root 7 over 4. It's ugly. It's really ugly, but the process doesn't change. I mean, here we had the 2, so I multiplied it by a half. I multiplied it by the half. That's where I got this was an 8. That's where I got this equal 57 over 16. And then I got my square root here. It works the same. It's just sometimes the numbers themselves just look blah. All right? And that's just the unfortunate event sometimes when you have coefficients that are equal to 1. Believe me, when we get to conic stuff, when you complete the square, the whole reason why I've been trying to show you guys how to complete the square is so that in a couple, well, next week, especially, we're going to be able to figure values out of what are called foci, major axis, minor axis, things like that. We'll be able to figure all these out via values after you complete squares. And the numbers, they're not going to look like that. Okay? So don't. Yeah, they'll look a lot prettier. I don't know. It depends. All right, it depends. Okay, it depends. What else did you want to look at on those review problems, then, guys? What else you got?
Yeah.
Well, if you did the wrong ones, were any of the wrong ones that you did? Remember, wasn't that? Oh, that was 8 you were talking about. 8. Well, 8. Remember, like I was saying with 8, it just means factoring. And then you said 18. Okay. Find the value of c that makes it a perfect square. Well, what's half of b? What's half of -0.6? Square it, you get 0.009. There's your c value. What? And a lot of things with that, I don't normally, and if you remember, I didn't assign any problems that looked like that, because why stop there? Why not just do the whole process? You know what I mean? Because you still got to take half of b and square it, and then you'd add it to both sides. Well, here they're just saying, hey, what makes it a perfect square? Well, half of -0.6 is 0.3. Square 0.3, you get 0.009. Oh, no, not at all. We're all out. Yes, ma'am. Yeah. You do, because you do the square root over the equal sign. Yep. Yeah, remember, anytime you take a square root over an equal sign when you're solving for x, you always have to have plus minus. Right? Whatever. It's funny, I was just watching Spaceballs last night. They jammed the radar. Raspberry, actually. Nobody uses it. That's Lone Star. I haven't seen it in forever either. I searched and my wife was laughing at me. She's like, 12? I'm like, yes I am. It's one of those movies. Anyway. What else? When you got when you did those last 3 about writing equations, were they okay? Was that work out okay with the points in the graph? That one you had to have it calculated. I don't know. Did you guys get 5:42.86 for 35? Okay, let's double check it. Hey, I just check it, right? Okay. So when you're working with these, remember you're filling in the blanks here. Ax squared bx plus c equals y. Do you guys know why I put y on that side? Because why? Okay. What comes first in the ordered pairs, x's or y's? X's. By putting the y on the right-hand side, it helps you remember that the first term is going to go into the x values, the y value comes last. Bless you. So I'm going to get 25a minus 5b plus 1c is 1. 16a minus 4b plus 1c is -2. Here's these 9s again. 9a plus 3b plus 1c is 5, which means my coefficient matrix is going to be 25, -5, 1, 16, -4, 1, 9, 3, 1. Inverse it to my solution matrix, 1, -2, and 5. So, what matrices? Yeah, matrices. You need more sleep. I just forgot the numbers. What were they again? The ones I just did. 25. It was 16. We have that 9, 3, and 1 all the time, don't we? It seems. And it's yes, absolutely. Because what's happening here in the matrix, what happens inside the matrix here, what it's doing by taking the inverse, it's taking the inverse, and when you do an inverse of a matrix, you have to do a lot of multiplying, and then you do a lot of division. What that does is it actually is solving the system of equations simultaneously. It's a really weird process that we just don't really teach all that much anymore. Well, what it's wind up doing, why it works where you have A, B, and C for your answers, bless you, because it's creating what's called an identity matrix. It's creating ones on the diagonal with the negative slope, and everything else is zeros. So that means your A value is something, your B value is something, your C value is something. That's what it's doing. Our solution matrix was, let's see, alpha, zoom 3 by 1. And it was 1, -2, 5, and then we hit enter. Bless you. It's okay. Math, enter, enter. And there you go. And yes, it is so easy. And if any of you guys did that problem, you got really awful, awful, awful stuff, you probably entered in something incorrect. Watch the video.
I got home at like freaking 10:45 last night.
Okay, I'm just saying, field trips and stuff, I'm kind of looking at things. All right. Yes, sir. What kind of stuff are used for? Matrices are used for solving large systems of equations. It's another way of gathering data and putting stuff together. It's another method for solving any system. Okay. Anytime you've got multiple equations with multiple variables and whatnot, you can put it all together and it solves it through. As you get into what's called linear algebra, you can start talking about what are called vectors, but there's all these different things that happen that are all determinants of things. That's what they all can be created via matrices. Upper level math is weird. There's so many weird things that happen, and it's kind of like, yeah. But in all honesty, like I said, one of the things that matrices are great, but it's one of those that's not super totally useful in a high school, except for this, because there's no reason that we need to solve a 3 by 3 by hand. That's just the kind of waste of time. Way I feel. Now, I will say one thing: on your standardized tests, when you see systems of equations, whether it's a 2 by 2 or 3 by 3 or anything like that, can you use a matrix to solve it? Absolutely. Absolutely. That's why these calculators are awesome. That's why I keep saying learn how to use it for your things, find a couple of these tips and tricks, because you will always see some sort of a system of equation on there, and it'll do it for you, even if it's a 2 by 2. Right. Excuse me. Yes, ma'am. I would prefer it, but it's not the end of the world. I'm trying to get you in the habit of, by showing you that I'm right in fractions, I'm hoping that over time, by the time we get to things that really get rid of fractions, you'll feel some kind of thing. Not too terrible. Any others on that question? On the things from last night that you want to double check, see how we did? Sure. Sure. Bless you. Apparently we're allergic to math. I look at one like this and I go to complete the square, I'm just going to go x squared minus 10x plus blah is negative 26. Move that over. I'll take half of negative 10, I get negative 5. I square it, I get positive 25. And then right away, I know that my answer is going to be x will equal 5 plus or minus 5. I find that completing the square is so much easier and a little bit quicker than quadratic formula. But there's no, you can go either way with it. It'll work just fine. I think quadratic formula, a lot of times, when you see something like this, you know that you could have factored out something from the denominator going upward because there's no fraction left over. See where I'm going with that? So sometimes this format is cleaner. Always worry about completing the square when your b value is even. I mean, odds are fine. It's just kind of a pain. Excuse me. Other than that, I'm trying to think if there's any other craziness here. Yes, sir. Yeah, you have to factor it out and then factor. Remember how I did that one at the beginning with that odd value? You have to bring it to the other side. So you take it out here, you got to put it back there. Because when you're adding that that half of b squared, you have to add that in conjunction with that first term to bring it over. Yes, sir. Yep. Sure. If I do a discriminant, hey, let's just use this one. If I want to do a discriminant, how many and what type of solutions is what that means. So I'm looking at what is going to be the b squared minus 4ac. Well, in this case, it's going to be 100 minus 4 times 1 times 26. So in this case, you get what? 100 minus 104. So I get negative 4 for my discriminant, which means there's going to be 2 imaginary solutions. Since this is the discriminant is negative 4, since the discriminant is negative, that means that there's going to be 2 non-real solutions, 2 imaginary. Correct. You can have 1 real solution, but you can't just have 1 imaginary solution, because imaginary solutions, which we'll talk about when we get to polynomials, they come in pairs. They have to come in pairs, because if you have, whenever you take the square root of a negative, you're always going to have plus minus. So no matter what, your imaginary solutions will always come in pairs. Whereas if you have 1 solution, that just means you touch the x-axis at 1 spot. That's when you have like jump squared, x plus 3, So it only occurs at negative 3. You can't have that happen with imaginaries, because there'll always be a positive solution and a negative solution. Does that make sense? Super exciting. What else we got? No, I mean red. Another reference. Holy Grail, somewhere now we're up to Forest, Spaceballs, Holy Grail. Sure.